Welcome to Amateur Radio's Reflector magazine by the East Coast Reflector. Volume 18 of the Reflector magazine, July 2025. Articles featured in this volume. Dick's Corner. The Antenna Farm High-Performance 70cm Yagi. The Great Quebec Blackout. Heatsinks. Power tool batteries for portable or ER ops. From World Radio History, Dayton. And Celebrity Call Sign with Hugh Downs and Peggy Sue. You'll also find information on the Western New York Meet and Greet, Nets, user-submitted pictures, comics, Ask an Elmer how to connect to ECR puzzles, ECR events, prayer list, silent keys, and more. Table of Contents.
A farewell cup of brew. Thank you, Mike, K2CMT. On June 26, 2025, we marked the end of an era on the East Coast Reflector. Mike K2CMT signed off as Morning Brew Net controller for the last time. For years ago, Mike and I launched the Morning Brew Net with one goal: to get people talking. It started modestly, a friendly net to bring voices together over coffee. Today it's grown into something far more powerful: a daily ritual, a lifeline for many, and a gathering place for over 140 check-ins. Worldwide each morning, Mike brought more than just a steady voice to the brew. He brought humor, compassion, and the kind of welcoming tone that made even first-time check-ins feel like part of the family. Mike's presence on the mic was a constant that helped shape the identity of the net. We can't thank him enough for his years of service, dedication, and kindness. Mike, your leadership helped build a space where people laugh, share, learn, and lean on one another. You've made mornings brighter for thousands of hams. While we'll miss hearing you call the net, we know you're not far. From all of us, thank you, Mike. 73 and enjoy that well-earned sleep in. You've brewed up a beautiful community. Thank you for a wonderful 2025 meet and greet. The East Coast Reflector brought amateur radio operators together in full force at the 2025 Western New York Meet and Greet, and what a turnout it was. Held at Chestnut Ridge Park, the event saw hams from near and far gather to enjoy good food, friends, and conversations. It was a special opportunity to put faces to call signs, swap stories, and meet old friends. This event was more than just a get-together. It was a celebration of the incredible friendships and teamwork that make the East Coast Reflector Network what it is. A standing ovation for our volunteers. We could not have pulled off such a fun, smooth, and memorable event without the help of our amazing volunteers. From the setup crews and grill masters to the organizers handling raffles, name tags, and welcome tables, your efforts didn't go unnoticed. A big shout out to our culinary crew for serving up delicious hamburgers, hot dogs, snacks, and drinks with a smile. We had a 50-50 and an impressive list of door prizes. The parking and setup helpers who made sure the event flowed from start to finish. Those who donated time and gear, making sure we had everything we needed, and more. You brought warmth, hospitality, and a real sense of community to the event. From all of us at ECR, thank you for making this event not just possible, but exceptional. Looking ahead to 2026. Planning for next year's meet and greet is already underway. We're taking your feedback seriously and hope to make 2026 even bigger and better, with more time to connect, more engaging activities, and of course, more radio talk. If you have suggestions, we're all ears. Reach out via the ECR Facebook groups, IO, or during any net. Let's make the 2026 event unforgettable together. The ECR. Look for full details in next month's magazine. But we can't wait that long to give a shout out to thank some of the people who made it happen. Volunteers and donors. Marcy W2EM/XYL Catering, main organizer. Chuck W2EM Grill Master, main organizer. Sal W2SAL, organizer. Corey N2BH/YL Serving. Terry K8BAC/XYL Door Serving. Tim KD2ONL Comms Parking Trailer. Steve AG2AA Communications. Angela N3ERBCW Jewelry, POTA Info. Matt K2EAG POTA Info, CW Jewelry. Bill N2BH Organizing. Al K8BAC Organizing. Scott W2BLT Coffee. Mark KE2EDS Door Prizes 50-50. Dick WB2 JPQ Main Organizer. Vicky KE8VKY Organizer. Dan KD2VNU Hot Dog Chef. Joe KO 4FRR Organizing, Setup/Teardown. Fred KZ20 Setup, Teardown. More picks. Ask an Elmer ? Have questions about radio gear, antennas, or how to get started in amateur radio? Stop by our Ask an Elmer sessions on the first and third Thursdays at 8 p.m. Laptop computer join Zoom at https://bit.ly/Eckerdaley. Open Mic Net Microphone. Become a net controller. Interested in becoming a net controller? Our Open Mic Net runs Wednesdays at 8 p.m., and we'd love for you to be part of it. We run our nets from a Zoom room, and you're always welcome to drop in and see how it works. If you'd like to participate, just fill out a contact form to get started filling out a brief contact form at bit.ly. ECR Town Hall Megaphone. We held our second East Coast Reflector Town Hall meeting, and the turnout was amazing. The feedback and questions help us better understand what the community wants and how we can improve. These town halls are now a regular thing. Join us on Zoom every second Thursday at 8 p.m. Eastern Time to learn, ask questions, and share your thoughts. Laptop computer join Zoom at https://bit.ly. U.S. Island Kayak Rove, Matt K2EAG and Angie N3ERB. If you missed in Zoom, you can still watch on YouTube. Matt K2EAG and Angela N3ERB shared their experience participating in the 2023 W/VEQSO party. Learn about how they activated 5 islands, all by kayak, as well as recent CW Kayak mobile POTA activations. ECR Magazine on YouTube. Did you know you can watch or listen to the East Coast Reflector magazine on YouTube? It's a fantastic resource for those with visual impairments or anyone who prefers to listen while mowing the lawn or tinkering in the shack. Give it a look and a listen. Connect to ECR. Connecting to ECR is simple and no membership. It doesn't matter if or what club you belong to. No fees or permissions. Everyone is welcome, and if you have audio issues, we're here to help. Simply free. The way that air was meant to be.
The TechNet. The TechNet is Tuesday nights at 8 p.m. Eastern and lasts for about 2.5 hours. Here's the order of the net. First, we share any ECR announcements we may have. Next, we take notices of any silent keys from the ECR. Next, we take check-ins from hams who are new to the net, where you can ask your tech-related questions and respond to help answer others' questions. And finally, we take general check-ins by call district. Tuesday nights at 8 p.m. and you can view the log at bit.ly/ECR logs.
Calendar. All times are Eastern. The following events are on the Reflector. For connection information, go to bit.ly/ECRconnect. Check out the Morning Brew Net on your way to work. Weekdays from 7 to 9 a.m. It can be pretty fast-paced. If you like a slower, more ragchu net, stick around on Fridays for the second cup at 9 a.m. Have a technical question? Stop by the TechNet Tuesday nights at 8 p.m. to ask your questions or offer your advice. Friday nights at 8 p.m., show your support by checking into the Youth Net. On Wednesday nights at 8 p.m., check out a new type of net, Open Mic Night for net controllers. If you'd like to give it a try, go to bit.ly/ECR Open Mic. On Sundays, listen to Amateur Radio Newsline at 1 p.m. and again on Wednesday nights at 10 p.m. We've also got HF Nets. On Thursdays at 10 a.m. join the 20-meter net on 14.317. And on Saturday mornings join us for the 40-meter net at 9 a.m. on 7.245. On Saturday nights at 11 p.m. Eastern, you've got to check out the Trivia Net. Everyone gets their own multiple-choice question. It's a lot of fun. For the following events, stop by the ECR Zoom room at bit.ly/ECR Daily. Every day at 3:30 p.m. stop by for advice or just casual conversation. On the first and third Thursdays at 8 p.m. Check out the Ask an Elmer Zoom room for people to seek information and get answers with the utmost respect, or to offer help to hams, or you can just stop by and listen. On the second Thursdays of the month, come in and be a part of our town hall meeting. We hope to see you there.
Pictures. User submitted pictures. 1 of 6.
The Antenna Farm. High Performance 70 centimeters Yagi. By Charles, KC6UFM. Hello, ECR family, and welcome to the Antenna Farm. This is your friendly antenna farmer, Charles, KC6UFM. As always with the Antenna Farm topics, I welcome any and all feedback from you, the reader. I'm almost always monitoring the East Coast Reflector, and my email is on my QRZ page. I am also on the ECR for almost every Tuesday night TechNet, so this would be a great place to ask questions too. Feel free to reach out to me with any comments or questions. But there's a new and, in my opinion, great place to ask questions about the Antenna Farm or antenna systems in general. Join me along with other Elmers in the East Coast Reflector Zoom room on the first and third Thursdays of each month at 8 p.m. Eastern for the Ask an Elmer Be an Elmer event. This is a chance for all hams, especially those new to the hobby, to ask questions that may be too involved to get answers from the TechNet. I look forward to you joining us and asking your questions. Today in the Antenna Farm, we're going to look at another antenna of my design. This particular antenna was developed when I was president of a local club that teamed up with another distant club that had a 70 centimeters repeater. I have personally built only 4 of these antennas, but others in the club built several dozen. This antenna is a high-performance Yagi beam for 70 centimeters, 440 megahertz, that is cheap to build, fairly easy to put together, and offers nearly 20 dBi of forward gain with deep nulls to the side and rear. Introduction. I first designed and built the prototype of this antenna back in 1995. As I said above, I have only personally built this antenna a few times, but other club members back in Missouri have built several dozen. The design is proven and performs very well. The antenna has changed very little over the last 25 years. My uncle always told me, "If it ain't broke, don't fix it, boy." That was usually reinforced with a palm slap to the back of my head. So I took the advice to heart. As I hinted at above, when I was the president of a local ham radio club in southeast Missouri, we teamed up with another radio club in the Cape Girardeau, Missouri area. The air distance was about 95 miles, while our local club had a 2M repeater. The club at the Cape had a 440 machine. At the time, the local area lacked the needed infrastructure to allow linking of the 2 repeaters via the internet, and using linked radios was prohibitively expensive for a small club of only a dozen or so members. The nearly 100-mile path was too much for a ground plane antenna, even with 50 or more watts of RF behind it. So it seemed that the answer was a high-performance beam antenna. This design was born from this situation. Design parameters. The top 2 considerations were low cost and easy construction. To make this possible, there were a few compromises made. First, the boom is made from PVC pipe and only 5 feet long. This is very cheap with a 10-foot section only costing about $9, and this will make 2 of the antennas. The compromise is that in areas with very hot temperatures, the PVC might sag a little. This effect can be mitigated by attaching the boom to the mast at the center instead of the end, as is tempting and perhaps desirable with this short of a boom. More on this later. Second, number 10 threaded rod was selected for the elements. Coarse or fine thread doesn't matter. Brass rod would be optimal, but it is a little costly at around $10 for a 3-foot length. Steel, preferably zinc-plated, will work just fine, and is only about $3 for a 3-foot length. Steel nuts and flat washers are similarly inexpensive. While we'll get into more details later, the construction is essentially cutting the threaded rod to the right lengths, drilling holes through the PVC boom at the right locations, then securing the element rods to the boom using flat washers, nuts, and some thread locker. And it's that bit about cutting the elements and drilling the holes that is the most difficult part as you go higher in frequency. The various dimensions of antenna parts get smaller. More importantly, the needed accuracy or tolerance also becomes more critical. When you're dealing with Let's say an antenna for 10M, an error in measurements of 2-inch is tiny compared to the wavelength. In this case, a 2-inch error is only about 0.5% at 10M. On the other hand, the same 2-inch error at the 70 centimeters band comes out to nearly 11%. Generally speaking, when building this antenna, all measurements need to be within about 0.5 millimeters of stated dimensions. And there's the other issue. In order to avoid some really bizarre fractional inch measurements, this antenna is designed using the metric system, with everything stated in millimeters mm. Yes, I know. Some people don't like using metric measurements. It's different and for some confusing. But when dealing with relatively small measurements that need a high order precision, metric is easier. I'll have to ask you to trust me on that. Don't rely on a tape measure or cheap ruler. Invest a few dollars in a good stainless steel meter stick. If you build more VHF/UHF antennas, you're going to need such an educated stick. The other consideration for this design is high forward gain and high directivity. This was accomplished by using calculations developed by DL6WU Gunnar Hawk back in the 1970s as a starting point. The element length and spacing were then tweaked to get the best possible performance. The results ended up being a forward gain of 19.25 dB at a 5 degrees takeoff angle with the back lobe down by almost 31 dB. In other words, this antenna put a whole lot of signal right on the horizon, exactly where you want it. Finally, I wanted something that would cover the entire 70 centimeters FM band from 440 megahertz up to 450 megahertz with VisWAR of 1.5 to 1 or less. Again, by adjusting the element dimensions, I was able to get a VisWAR of 1.09 to 1 at 440 megahertz and 1.51 to 1 at 450 megahertz. For most of the club members who built this antenna, it was in a fixed position aimed at the 440 repeater in Cape Girardeau, so no rotator was needed or used. One of the versions that I built was on a rotatable installation, and a small, cheap Radio Shack TV rotator was actually a bit of overkill. In a nutshell, just about anything stronger than a hamster in a wheel will turn this antenna. Materials. Despite the need for precision in construction, the design is flexible enough to allow for some substitution of materials. With that said, be careful when making substitutions. This design is very sensitive to changes, and it is already tweaked to very near theoretical maximums for gain, directivity, and bandwidth. There's very a high probability that changes will degrade the performance. The boom. Just like all Yagis, you need a boom. The boom is only 5 feet long. The design calls for 1 1/4 inch PVC pipe for boom, and this pipe has an outside diameter of 1.66 inches. You can use Schedule 40, 80, or even 160 pipe, and nothing will be impacted. The outside dimension stays the same, only the wall thickness, and therefore the inside diameter changes. If you live in an area with high winds, high temperatures, or heavy snowfalls, Schedule 80 pipe might be an advantage. But in most cases, Schedule 40 will do the trick. You could use some other non-conductive material like wood, but the moisture in the material may impact the antenna. Fiberglass is another good option, though it can be pricey and hard to work with. Do not use carbon fiber. It conducts. Figure 1. Elements. The design calls for number 10 threaded rod. It doesn't matter if you use fine or coarse thread. Just make sure that the nuts used to secure the elements in place match the rod you use. A 5 millimeters threaded rod will also work with appropriate nuts and washers. You should avoid using any other size rod. Using a smaller or larger diameter rod will radically degrade the antenna performance. In a perfect world, brass threaded rod is the best choice. It's resistant to corrosion, has lower electrical resistance, and is easy to cut. It's also expensive. Steel threaded rod will, in practice, work just fine, though you should get zinc-plated rod to increase the resistance to corrosion. Steel rod tends to be about 1/3 the cost of brass rod. Resist the urge to paint the element rods. Many paints are at least semiconductors and can change the electrical properties of the element. Applying a little bit of silicone sealant to the cut ends to prevent corrosion is just fine. I know of one person who used stainless steel rod. It worked well, but the costs are higher than steel, though less than brass. The biggest issue with stainless is that it is harder to work with. You will need about 11 linear feet of threaded rod. Mounting plate. You need some way to mount the round antenna boom to the round mast. At its simplest, this is just a plate with appropriate holes drilled to allow for U-bolts clamping the two pipes together at a 90 degrees angle. As with all Yagis, this antenna can be mounted with the elements parallel to the ground for horizontal polarization, or the elements perpendicular to ground to give you vertical polarization. Which you choose depends on what you will use the antenna for in your setting. If you plan to use this antenna for weak signal SSB CWFT8 work, you will likely be better served mounting the antenna for horizontal polarization. Almost all repeaters, however, are vertically polarized. If you plan to use the antenna for repeater access, then you want to mount the antenna with the elements perpendicular to the ground. But this creates an issue. The mast will be running vertically up to the boom and will have an impact on the antenna's performance. If that is, the mast is some conductive material. The easy solution here is to use some non-conductive material for the mast, whereas inside the area of the antenna elements. This could be almost anything strong enough for the job, including PVC pipe, Schedule 80 or 160 highly recommended, fiberglass, wood, whatever. There's a way to totally avoid this issue, though, and on a small antenna like this, it is entirely possible. Extend the boom several inches behind the reflector and mount the antenna to the mast behind the antenna's reflector element. This installation will look like the antenna is a pin stuck into the mast pole. If you go this route, you should use Schedule 80 or 160 PVC pipe for the boom to minimize sag and increase strength. The image below shows a commercial antenna with this mounting option. Figure 2. Miscellaneous supplies. There are a few other supplies you will likely need. Tape or zip ties to secure feed lines and other things the boom is needed. Silicone sealant to seal the boom end caps and element holes. Loctite thread locker. Blue will work, red is better. Other similar brands will work. End caps to fit the ends of the boom. JB weld to secure feed point items. Similar strong, weatherproof, UV-resistant epoxies are fine. Your particular construction might need other things depending on how you customize the antenna to your particular needs. Performance diagrams. Before we get into more details of construction, let's take a look at some performance diagrams for the antenna. All diagrams are from the ESNEC model mounted 20 foot above a typical ground at 445 MHz. This first image is the antenna itself as displayed in ESNEC. The reflector is to the left. As you can see, the antenna is a 10-element Yagi. Note that the element spacings are not uniform. This is done to get maximum gain and directivity. The elements are shown oriented for horizontal polarization, but everything still applies when positioned for vertical. I just find it easier to tweak element lengths and positions in the horizontal mode. Figure 3. Next, we have two different VisWar curves plotted. Figure 4. The image above is the VisWar from 440 MHz to 450 MHz. Since this antenna was initially designed for FM repeater use, this curve was of the most importance. However, Figure 5. The above plot is a VisWar from 420 MHz to 450 MHz, and so covers not only the FM portion of the band, but also the lower segment where CWSSB or FT8 and more lives. As you can see, the VisWar is below 1.5 to 1 across the entire range. Figure 6. Above is the azimuth pattern plot at 5 degrees angle above the horizon. You will note that the maximum forward gain is just over 19 dB, and the worst K-side lobes are down by almost 20 dB. Our last image below is the elevation plot for the antenna. Again, at 5 degrees, the gain is nearly 20 dB. Figure 7. Element dimensions. The table below gives the dimensions for the several elements of the antenna. The columns have meanings as follows. Element, what the rod at this location does. Length, the total length in millimeters of the rod. These values are in millimeters mm and have a tolerance of plus or minus 0.5 millimeters. Location, this is the point along the boom that the element is mounted, all measured from one end of the boom. These values are in millimeters mm and have a tolerance of plus or minus 0.5 millimeters. Element dimensions chart. If you want to do the math, 1,470.07 millimeters is about 58 inch, so the entire antenna will fit on a 5'60" boom. It's worth noting that the above measurements are all exact dimensions. The tolerance of plus or minus 0.5 millimeters allows you to safely round the decimal measurements up or down to the nearest whole numbers of millimeters with limited impact on performance. With that said, try to get as close as possible. Just a little tip for when you start cutting the elements. Use some masking tape or something to mark each element as you cut it, telling yourself what the element is for. The elements are only about 2 millimeters different from the elements on either side of them, and it's easy to get them mixed up. Lastly, in terms of element placement, it's very important that the elements be mounted with the center of the several elements in a straight line. Preferably, this line will be on the center line of the boom. In other words, a given element must have the same overhang on both sides of the boom. With this in mind, I suggest that if you can, use a drill press to drill the holes, and use V-blocks to hold the boom as you drill to keep things lined up and well centered. Location, location, location. As with all antennas, higher is almost always better. With that old adage out of the way, let's look at the practical side of things. This antenna was designed to be mounted at least 20 foot in the air. Higher will be usually better. There are a few esoteric situations where lower might be better for a particular installation, but these are very rare. Get the antenna as high as you can safely put it. Keep in mind that there will be a twisting moment on the mast/tower. Also, if using a rotator, keep the length of the mast above the rotator short. Ideally no more than about 6 feet or so, but see the rotator specs to be sure. Be sure to guide your mast/tower. We're not talking about ground plane here. Beams, even small ones like this, can in high winds twist an unguided mast or tower like a wet shoelace. The odds are when you are erecting your new antenna, you will need to get some help. One person can do the job, but it's both easier and safer to have some help. Feeding your new beam. There are 2 ways to feed any Yagi antenna. The first way is to treat the driven element like a normal dipole. Basically, you cut the driven element in half and attach the 2 leads from a feed line to the 2 segments. With this feed, you need to keep 3 things in mind. First, the ends of the 2 segments must be as close together as possible without allowing for shorts or arcing at high power levels. You can, if desired, put some kind of insulator between the ends. Second, you will need to shorten each segment by 1/2 of the spacing. And third, you will need a common mode choke on the feed line because the dipole is a balanced antenna and the coax is unbalanced. The image below shows the basic connection for a direct feed. Figure 9. The second option is to use a gamma match, as is common on commercially made Yagis. Note that other similar matches like the Delta and T will also work, but the gamma tends to be simpler. To build a gamma match, leave the driven element in one piece and mount it to the boom just like with all the other elements. You will then connect the coax shield conductor to the exact center of the driven element rod, and the coax center conductor will connect the second rod, the same material as used for the element, that is about 125 millimeters long and spaced about 15 millimeters from the driven element, extending from the center position on the driven element to one side. There's a sliding strap to short the gamma rod and driven element together that will allow you to adjust the match to the antenna. With a gamma or other match, there is no need for a common mode choke. The matching section takes care of this. The image below shows a typical gamma match. Note that the variable capacitor is optional, but if used, it should be a high voltage unit for more than about 100 watts and have a value in the 0 pF to 20 pF range. Figure 10. There is an interesting option for the gamma match capacitor. Use a small, low-voltage adjustable capacitor to tune the antenna using your nano VNA or antenna analyzer. Then, using an LCR meter, measure the value of the capacitance needed to get the match. Lastly, put a fixed value capacitor of an appropriate voltage rating in place of the variable unit. Seal everything, and you're good to go. Either the direct or the gamma feed will work well for you. Many of these antennas have been built using both options, and it's really a matter of what you like. With that said, I will, however, recommend that you use the gamma match method. The gamma match will allow you to leave the driven element alone. No cutting, no trying to adjust the VSWR by trimming the element. No trying to get the two pieces to be symmetrical around the boom. It's just easier. Also, and maybe of more importance, the gamma match will allow a wider range of adjustment to get your VSWR, and therefore your match, as low as possible, especially if you use capacitor. To build the gamma match, you need to cut out a small section of the PVC pipe boom directly above the point where the driven element passes through. The hole needs to be large enough to give you access to the element rod. To attach the coax shield to the rod, make sure the connection is secure before sealing the hole with silicone rubber sealant. Next, take the small gamma rod and attach the coax center conductor to one end and use epoxy to secure the rod to the boom extended to one side parallel to the driven element rod. Fabricate a sliding strap to connect the gamma rod to the element. To tune the antenna using an antenna analyzer or nano VNA, check the VSWR as you move the slider back and forth and optionally adjust in capacitor to find the lowest reading. It will take a little time and patience, but it can be done once you find the best match. Secure the strap to the two rods and apply a thread locker to the strap screws and, optionally, the variable capacitor shaft. No matter what feed option you use, be sure to properly seal all holes you make in the boom and the exposed ends of the coax to prevent water egress. Now we need to look at your feed line choices. I strongly recommend using at least LMR 400 or Belden 9913 coax. LMR 600 or Hardline is better, but LMR 400 and Belden 9913 will work and are cheaper. Why do I make this recommendation? Look at this table. Figure 11, high performance 70 centimeter Yagi coax loss. Keep in mind that each 3 dB of loss cuts your signal in half, and this applies to both transmitted and received signals. In other words, if you have 100 foot of coax at 450 megahertz, apply 100 watts of power from the transmitter, and you're using RG8X, the antenna will only get about 14 watts to radiate. And this is assuming that you have a perfect 1:1 VSWR. As the VSWR goes up, the losses get bigger and bigger. Under the same conditions, but using LMR 400 coax, your antenna will get nearly 52 watts. With LMR 600, the antenna sees nearly 66 watts. If you can afford it and use 7/8-inch iliacs, the antenna will see about 82 watts. And then there are the coax connectors. At UHF, the idea of using type N connectors starts to make sense. The traditional UHF connectors, PL 259/SO 239, aren't really suitable for use at UHF. In the 1930s, when the connectors were developed, the definition of UHF was different, starting at around 30 megahertz. There are multiple issues with UHF connectors at 450 megahertz that are beyond the scope of this article. But just because Yaesu Icom, Kenwood puts in SO 239 on their 70 centimeters radios does not mean it's a good idea. At UHF frequencies and higher, you need to bite the bullet and buy the really good stuff. Conclusion, there you have it. A high-performance antenna for 70 centimeters work. As with any antenna construction, take your time and pay attention to details, and you'll have an antenna that will perform well and that you can take pride in having built and owning. I again want to remind you that this antenna is radically tweaked to get maximum performance. This means that all of the dimensions for element length and placement are very critical. Measurement errors over 1/2 of a millimeter, about half the thickness of dime, will degrade the antenna's performance. Please feel free to contact me on the ECR at the Tuesday Evening TechNet, in the Ask an Elmer/B and Elmer Zoom meetings, or via email if you have any questions. I'll be happy to help. Next time on the Antenna Farm, we're going to start a series of related articles on antennas suitable for space communications work, including satellites, ISS, and YEMI. If you know of an antenna construction article on the web, please drop me a note with the pertinent information, and I will look at it for consideration as an article for the Antenna Farm. Take care and 73. Charles, KC6UFM.
The new ECR helpline. If you're having connection issues or repeater issues and need help connecting, call our helpline at 746-427-4142. We'll help you the best we can. Also, if you find a major problem on the system, please report it to the same number at 746-427-4142. This is not for bad audio or rude hams. This is for things that need current attention, like someone sleeping on the mic about to time out the system or someone being very aggressive. We appreciate your help.
Open Mic Net. The ECR has a one-of-a-kind net. It's an open mic net for net controllers. Every Wednesday night at 8 p.m., we have multiple guest net controllers. You can be on too. No experience necessary. You don't even need to log. If you're interested in being a net controller on our open mic net, sign up at bit.ly/ECR open mic.
ECR Town Hall Virtual Meeting. The ECR is at it again. You matter. Stop by our ECR Ham Town Hall meeting. Hear announcements and learn about new events. Offer suggestions. Or find ways to help. We didn't get this big by thinking of ourselves. We did it by thinking of you. Stop in and help us get to know you. It's the second Thursday of each month in the ECR Zoom room. That's 8 p.m. Eastern at bit.ly/ECR daily.
Pictures. User submitted pictures. 2 of 6.
Birthday call sign word search. Try the birthday call sign word search puzzle. Click on the magazine page and solve it online or to print it. If you'd like to be added to our birthday list, go to bit.ly/ECR birthday. The Great Quebec Blackout by Randy W. 2RBC. On a hot summer day in 1998, the province of Quebec experienced a massive blackout that lasted for over 30 hours. The event is now known as the Great Quebec Blackout and had a significant impact on the lives of millions of people in the province. The blackout occurred on August 14, 1998, at around 3:20 p.m., when a power line in upstate New York failed, causing a chain reaction of power outages across the northeastern United States and southeastern Canada. Within minutes, more than 6 million people were without power, including over 2.6 million people in Quebec. The impact of the blackout was immediate and widespread. Traffic lights stopped functioning, causing traffic jams and accidents. Elevators stopped working, leaving people trapped in buildings. Hospitals and nursing homes were left without power, causing concerns for the safety and well-being of patients and residents. Grocery stores were forced to close, leaving people without access to food and other essential supplies. The Quebec government declared a state of emergency, and the military was called in to assist with relief efforts. Emergency services worked around the clock to restore power and ensure the safety of those affected by the blackout. The cause of the Great Quebec Blackout was determined to be a combination of factors, including human error and a lack of proper maintenance of power infrastructure. The power line that failed in New York was not properly maintained, and the failure caused a domino effect that led to the widespread blackout. The Great Quebec Blackout serves as a reminder of the importance of proper maintenance of power infrastructure and the need to invest in alternative sources of energy. It also highlights the impact that a power outage can have on the lives of millions of people and the need for emergency preparedness. As amateur radio operators, it's essential to understand the impact that events like the Great Quebec Blackout can have on our lives and the importance of being prepared for emergencies. Here are some tips to help you prepare for a power outage. 1. Create an emergency kit. Put together a kit that includes essential items such as flashlights, batteries, first aid supplies, and non-perishable food. Make sure to store the kit in a location that is easily accessible. 2. Have a plan. Create a plan with your roommates or family members that outlines what to do in the event of a power outage. Make sure everyone knows where to meet and how to stay safe. 3. Charge your devices. Before a potential power outage, make sure to charge all your electronic devices, including your phone and laptop. 4. Stay informed. Keep up to date with local news and weather reports to stay informed about any potential power outages or emergency situations. By following these tips, you can help ensure that you are prepared for a power outage or emergency situation. Remember, it's always better to be prepared than caught off guard.
The text check-in line. Grab a pencil. The ECR has a unique way to get more people on the air. Our nets can be so busy that people have a difficult time getting in. We want to help everyone get on the air. So here it is, 716-317-9050. Text your call sign to 716-317-9050. This will get you onto the log. This is not for ins and outs. It's to help get people on the air and through the pileups. Text your call sign to 716-317-9050.
The Trivia Net. The Trivia Net is a fun, unique net. Check into the net, and you'll be asked a multiple-choice question when it's your turn. Saturday nights at 11 p.m. Eastern.
Ask an Elmer Zoom event. Ask an Elmer be an Elmer. Join us on the first and third Thursday of each month. Come in and ask for help and get respectable answers from a family-friendly environment. If you don't have any questions, just come on in to watch and listen. Pictures. User submitted pictures. 3 of 6.
Jigsaw Puzzle. Enjoy a simple little puzzle right here on your device.
Heatsinks by Harry Lythall, SM0VPO. Introduction. Projects often require a lot of heat to be conducted away from a device generating it. Constructors often guess at the size of heatsink, then build. I used to be that way myself, but in the late 70s I began using power transistors, and the tears began. I had to educate myself. After a few experiments, I developed rough formulas for estimating the size of heatsink needed. Power and heat. A silicon transistor should not normally be allowed to become much hotter than about 100 degrees Celsius. Most transistors will happily operate hotter, but do not count upon it. Let us take the case of the simple PSU described earlier. The PSU may deliver 3 amperes at up to 15 volts. What equals volts times amperes? The load is therefore dissipating 3 times 15 is equal to 45 watts. With a pre-regulated voltage of 24 volts, the regulator transistor has the remaining 9 volts across it, also at 3 amperes. The transistor is therefore turning 27 watts, 9 volts times 3 amps, into heat. If you now turn the output voltage of the PSU down to 3 volts, the problem gets much worse. The load is now taking 3 times 3 is equal to 9 watts, and the transistor is dissipating. 24 volts minus 3 volts times 3 amps equals 63 watts as heat. What do we do with all this heat? Use a heatsink, of course, but how big? Heatsink characteristics. Heatsinks are given a characteristic, degrees Celsius, divided by watts. A25 transistor, for example, without a heatsink has a case heatsink characteristic of somewhere in the region of 220 degrees Celsius per watt. So for every watt you make it dissipate, it will increase its temperature by 220 degrees Celsius, or about 240 to 250 degrees Celsius at normal room temperatures. That's hot enough to melt solder. A clip-on heatsink with a characteristic of 40 degrees Celsius per watt will limit that device to 40 degrees Celsius plus 30 degrees Celsius room temperature equals 70 degrees Celsius. With the heatsink, the transistor will therefore survive. The heatsink simply conducts heat away from the device and dissipates it into the room. So the larger the surface area, the lower or better the degree C/W rating that heatsink has. Size of heatsink. Our transistor in the PSU is dissipating 62 watts. So to keep the temperature below 100 degrees Celsius, we should calculate the smallest heatsink required. The room temperature is assumed to be 30 degrees Celsius, so the transistor can increase its temperature by only 70 degrees Celsius. 70 degrees Celsius divided by 62W equals 1.13. So we will need a heatsink rated at 1.13 degrees Celsius per watt or less. Most component suppliers' catalogs give a heatsink's degree C per W characteristic. You can evaluate homemade heatsinks by using the following rough formula. Formula image. As an example, let us make a heatsink with 18 SWD aluminum sheet, folded as shown, viewed from above. Image. The heatsink is going to be 20 centimeters wide, 10 centimeters deep, and 12 centimeters high. Each fin is 10 centimeters times 12 centimeters equals 120 centimeters. Each fin also has two sides. Area equals 240 square centimeter. There are 10 fins, so we have a total of 2,400 square centimeters. The rear plate is also two sides times 20 centimeters times 12 centimeters equals 480 square centimeter. Total area equals 480 plus 2,400 is equal to 2,880 square centimeter. Since image and the square root of 2,880 is equal to 53.66, we therefore have 50 divided by 53.66 equals 0.932 degrees Celsius per watt. That would be an expensive heatsink to buy. It may not look pretty homemade, but it works just as well. Use existing heatsinks. It is common practice to use the chassis of a unit as the heatsink, or part of it. An aluminum box 5 centimeters times 10 centimeters times 20 centimeters would therefore have an outside surface area of 5 times 10 times 20 is equal to 1,000 square centimeter. Square root of 1,000 is equal to 31.623. So our equipment case has a thermal dissipation of 50 degrees Celsius divided by 31.623 watts equals 1.58 degrees Celsius per watt. Since we need 1.13, we do not have enough. But we can use the case to cut down the size of the heatsink we need. Notice that the inside of the case was not taken into account. The case is a closed box, so without ventilation, the inside of the case will dissipate nothing. How big do we need it? Okay, now let us work backwards using our PSU regulator transistor that is still dissipating over 60 watts without a heatsink. Let us mount it in the 5 centimeters times 10 centimeters times 20 centimeters cabinet we found above, transposing the formula we have. Image. We know we need a heatsink of 1.13 degrees Celsius per watt, so putting this into the formula, we get 1957.9 square centimeters of heatsink required. We already have 1,000 in the case, so we must provide the other 960 as fins on the back. 10 fins of 96 square centimeters, 48 per side, will do the job. Each fin can therefore be 5 centimeters times 10 centimeters. Forget the backplane, that is part of the case. 5 centimeters times 10 centimeters is still quite big, but the case is only 5 centimeters deep, so it is reasonable. Including heatsink, the case will now be 5 centimeters times 20 centimeters times 20 centimeters. Note that only the fins were considered. In reality, a 5 centimeters tall case would be a little small, so the case would not be able to accommodate the mains transformer, even if you use 3 6.3 volts, 3 amps filament transformers. Increasing the height of the case by 1 centimeter would reduce the size of the fins by 2 centimeters, 6 centimeters times 8 centimeters, as opposed to 5 centimeters times 10 centimeters earlier. Mounting devices. Almost all devices that we need to mount on a heatsink have a metallic surface from which the heat is to be conducted. This surface is usually electrically connected to one of the terminals of the device. We therefore need to place an insulator between the device and the heat sink. In the case of transistors, this is in the form of a mica washer or disc. The disc is lubricated with a heat-conductive oil to help the heat to be transferred. The oil and the washer should never be omitted if the device is to be effectively protected. Since aluminium is not the world's best conductor of heat, I usually lay a strip of copper the full length of the heatsink. The device is mounted on the copper, and the copper distributes the heat to the rest of the heatsink. And finally, there are such things as temperature gradients, junction to case thermal resistance, and many other parameters that could be investigated. If the subject of heatsinks were an English country mansion set in 110 acres of garden maintained by over 50 servants, I have just shown you the doorbell, or just enough to get you in the door and out of trouble. So, that is about all I want to say about heatsinking. Do have fun, but don't get your fingers burned. Best regards, Harry, Lunda, Sweden. Message board. Original article can be found at sm0vpo.com.
Connections printable. There are many ways to connect to ECR. For a printable list, go to bit.ly/ECR Connect. There, you will find the information to connect via ADN, DMR, DV switch, Echolink, Hamshack Hotline, Hams over IP, IRLP, and Yaesu Fusion.
The Youth Net. Join our Youth Net controllers every Friday night. Support the future of ham radio. Friday nights at 8 p.m. Eastern Time.
Railroad frequencies. Click this page in the online PDF magazine to print this copy of Railroad Frequencies.
Pictures. User submitted pictures. 4 of 6.
Power Tool Batteries for Portable or Emergency Operation by Dave, KD8EVN. One of the best traits of amateur radio is how hams are open to sharing experiences and ideas on how to improve their hobby. I have had many compliments on the design of my grab-and-go radio setup, but I always let the person know it is not my original design. I saw Steve Stalker, KC8TVW's design for his grab-and-go radio back in 2007 and made mine like his and have always thanked him for the inspiration. To power my portable radios, I have always looked for a solution to not have to use a large, heavy battery. With more tools, lawn mowers, and even chainsaws becoming battery-powered, there had to be a solution to use an 18, 20, or 40-volt tool battery. Seeing the cover story of QST magazine for July 2024, I found the solution to my heavy battery problem. Power Tool Batteries for Portable or Emergency Operation by Gordon S. Novak Jr., AF5KA. He presented a solution for using small, light, rugged tool batteries to power our radios in the field. He used a DC converter originally used for golf carts to take their battery voltage down to 13.8 volts to run tape and CD players while they cruise the golf links. I was never a fan of golf or golf carts, but what an outstanding way to power our radios in the field. The converter is light, waterproof, and very easy to wire and set up. All my tools are DeWalt, using 20-volt, 3 or 4 amp batteries. You can find an adapter connector that your tool battery slides into. The DeWalt tool adapter I use as wiring, fuses, and an on and off switch which wires up quickly to the converter wires. A 20-volt 8 amp hour battery will power a 100-watt transceiver for a few hours. AF5KA Gordon's QST article is very detailed on how to safely use batteries and the converter and use Schottky diodes to wire battery packs together for longer life and more power. Please read his very well-written article on all the safety factors and check out the link below for extra information. www.cs.utexas.edu. If you travel light, you will operate with comfort in the field. 73, Dave KD8EVN.
Audio check. There's a great audio tool on the website at eastcoastreflector.com. Now we have a second audio feed. One has a 2.5-minute delay, and the second is real time. If you need an audio check to hear what your audio sounds like, load up Listen live on the website, pick up your radio, give your call sign, and say, "This is an audio test." No response necessary. Still stumped? Come into our Zoom room for advice at bit.ly/ECR Daily.
The Morning Brew is a light-hearted, fast-paced net. Check in and tell your barista your answer to a simple question to get your morning brain started. Mobile check-ins are given priority. Don't want to deal with the pile-ups? Text your call sign to 716-317-9050 to get on log.
ECR Gift Shop. Help to support the East Coast Reflector at the gift shop. Baseball caps from $18.99, coffee mugs from $11.20, and t-shirts from $18.74. Check us out at eastcoastreflector.com.
Radio Crossword Puzzle. Click on the original PDF of the magazine to fill out the Amateur Radio Crossword Puzzle.
Pictures. User submitted pictures. 5 of 6.
The World Radio News. May 1975. Dayton. By Bill W2DD. Courtesy of World Radio History. Rack up another smashing success for the Dayton Amateur Radio Association. Amateurs 10,000 strong attended the Doris Hamvention April 25, 26, 27. Banquet attendance was 1,600. No one who attended will ever forget the sea of campers, trucks, and private cars comprising the absolutely gigantic flea market. It was a really big show. Highlights of the Saturday night banquet included the issuance of 2 highly coveted awards and an address by Ambassador Armin H. Meyer, W3, AC. Winner of the 1975 Hamvention Amateur of the Year Award was Dick Daniels, WA4DGU, of Arlington, Virginia. Dick's work in practically every phase of satellite work was the basis for his award. The Honorable Stanley Phillips, who delivered the award, listed license procurement, data supplied at FCC hearings, design, construction, and the installation of satellite gear in space vehicles among Dick's outstanding achievements. Gene Kunder, W8YK, of Delphos, Ohio, was given the 1975 Hamvention Achievement Award for being the first amateur in the world to complete a 2-way exchange of SSTV pictures with 100 countries. Gene has them all confirmed and is on his way to the second 100. Ambassador Meyer, who has served as U.S. Ambassador to Japan, Iran, and Lebanon, delivered a thought-provoking address. The main thrust of his talk was to encourage the recognition of amateur radio as a human resource not only here in the United States, but also in the so-called emerging countries where any form of radio communication is sometimes regarded with suspicion. Ambassador Meyer noted that the use of radio and electronics by amateurs could greatly enhance the potential supply of technicians and engineers in countries where technological progress has been very limited until recently. Looking forward to the 1979 ITU conference, Ambassador Meyer stressed the point that for the continuance of viable frequency allocations and reasonable operating privileges, amateurs everywhere must take action to persuade their governments that amateur radio is in each country's own interest, a human resource rather than an insignificant hobby. Master of ceremonies for the banquet was Dan Graves, WN8KST, whose Art Carney-like style kept the Ventillon crowd wide awake and happy the Hamvention Committee is already at work on next year's program, but everyone who made the scene this year will tell you that they'll have a tough time topping 75. A suggestion to Hamfest committees everywhere: if you want a postgraduate course in hamfestmanship, go to Dayton and learn from the pros. Congratulations to President Bob Wilson, W8JRN, and his Dara Hamvention Committee.
You should know. The East Coast Reflector and its Reflector magazine is all volunteer-run. We charge nothing to use the system. We charge nothing to subscribe to the magazine. The system has hundreds of users connected at any given time. We incur a lot of expenses to maintain such a large system. If you use the system or enjoy the magazine, please consider helping by contributing to the system by going to eastcoastreflector.com and click on Donate. Your contribution is greatly appreciated.
Nets. The ECR has nets for everyone, including HF nets.
Social media. The ECR is building up its social media presence. Join our Facebook group so you can enjoy our ham radio content and stay up to date on ECR information, and so you can update us on your ham shack and ask questions. Just like on the air, we don't tolerate trolls. You're free to ask questions troll-free. We keep it an enjoyable place. Check us out also on X, Twitter, Groups.io, and YouTube. We look forward to you joining us.
ECR Gift Shop. Help to support the East Coast Reflector at the gift shop. Get your call sign put on an ECR shirt starting at $17.68, coffee mug from $12.60, or a polo from $22.49. Pictures. User-submitted pictures. 6 of 6.
Celebrity call sign. Hugh Downs, American broadcaster by KD2TFB. Hugh was born on February 14, 1921, in Akron, Ohio, to Edith and Howard. He was educated at Lima Shawnee High School in Lima, Ohio, Bluffton College, a Mennonite school in Bluffton, Ohio, and Wayne State University in Detroit, Michigan. Our celebrity worked as a radio announcer and program director in 1939 at WLOK in Lima, Ohio, after his first year of college. In 1940, he moved on to WWJ in Detroit. Hugh served in the United States Army during World War II in 1943, and then joined the NBC radio network at WMAQ as an announcer in Chicago, where he lived until 1954. He then attended Columbia University in New York City in 1955 and 1956. Hugh made his first television news broadcast in September 1945 from the still experimental studio of WBKB-TV, which is now WBBM-TV in Chicago. He once said that when he went for his first job, he had never seen a television before, and he was unsure whether television would last. Well, as we know now, last it did, because in 1984, Hugh was certified by the then Guinness Book of World Records for the greatest number of hours on network commercial television at 15,188 hours. That would later be bested by Regis Philbin in 2004. Our celebrity is a published composer, having hosted the PBS Showcase for Classical Music live from Lincoln Center from 1990 to 1996. But perhaps the two television things he is best known for is being host of Concentration and the ABC News show 2020. This celebrity call sign is KD6WSUS, having belonged to Hugh Downs. Of course, as with people born that long ago, Mr. Downs is a silent key, having passed away on July 1, 2020, of heart failure at his home in Scottsdale, Arizona, at the age of 99. Thanks go to the ARRL website for the tip, and like many of these episodes, the English language Wikipedia, and is therefore subject to the Creative Commons Attribution Share-alike 4.0 license.
The Reflector magazine is on YouTube. The Reflector magazine is available on YouTube. You watch along on the pages and listen to the voiceover. It's great for blind, visually impaired, people who prefer to listen to the audio, or people who need something to listen to while they mow the lawn. If you know of someone who would benefit, pass it along.
Net questions. Here's a list of most of our net questions. Ever wonder how your answer compares? Click the question to see the results. There's questions from The Morning Brew, the TechNet, and the Trivia Net.
Nets. The ECR has nets for everyone, including HF nets.
Be a contributor. Want to help contribute to the magazine? Send in your article, project, story, comment, and suggestions to editor@ecr@gmail.com. You don't have to be a good writer if you have a good story. Everything will be published and sent to you before it's published.
Aeronautical Zoom presentation. If you missed Carlos N1CBM's incredible presentation, you'll want to catch the replay on our YouTube channel. Carlos walks us through the many antennas you see on aircraft. It turns out that all of those bumps and bulges that aren't just vents or lights, but antennas. Many antennas. He does a great job explaining the purpose and function of each. It was an incredibly interesting presentation. Watch it at youtube.com/East Coast Reflector.
Celebrity call sign Peggy Sue. Inspiration for Buddy Holly's hit song Peggy Sue by Joe, KD2TFB. The place was Lubbock, Texas, and the year was 1956. Alto sax player Peggy was on her way to the Lubbock High School band room when she ran into someone in a big hurry. "I'm terribly sorry, but I don't have time to pick you up," the man in a hurry said, as Peggy later recalled in her autobiography. The following year, the whole world would hear about our celebrity as the Crickets would release a song about her and help propel the band to much fame. But tragically, a couple of years later in 1959, the band would suffer a great loss, the incident which would be noted by Don McLean as the day the music died. Peggy was actually married for 8 years to Crickets drummer Jerry Allison. This celebrity call sign is K5PSG, belonging to Peggy Sue Guerin, the reason for the title of the Crickets song. Sad to say, she became a silent key on October 1st, 2018, at the age of 78. The sources for this week's celebrity call sign are the New York Times and Northern California Public Radio.
Want to see where you are on the log? Watch along. Go to bit.ly/ECR logs to get access to view all of the net logs. A list of useful links and our facilitators.
Please pray for Cindy, wife of Charles, KC6UFM. KB2UDB Mike and his wife Deborah. KC4BB George Billy, Broadway. Silent Keys. Care 7KZ Jerry from Kingman, Idaho. Please keep these people and their families in your prayers to give them the strength, encouragement, comfort, and peace of mind and heart they need, and have a brief moment of silence.
Thank you for listening to the Reflector magazine. If you'd like to subscribe, go to bit.ly/ECR subscribe and enter your email. Disclaimer: the content, opinions, and views expressed in this magazine are those of the authors and contributors and do not necessarily reflect the opinions or views of the publisher, editorial team, or affiliated organizations, or anyone else. All articles, images, and information provided are for informational and entertainment purposes only and should not be considered as professional advice. The publisher, ECR, and its volunteers assume no responsibility for errors or omissions in the content provided. Readers are encouraged to verify all information independently. The use of trademarks, logos, and brand names does not imply endorsement. Reproduction or redistribution of any content in this magazine, in whole or in part, without prior written consent from the publisher, is strictly prohibited. For inquiries or permissions, please contact Vicky, KE8VKY at KE8VKY@gmail.com.